Alright guys, welcome back to another lesson here. Today we're going to be talking about some special products of polynomials. Basically, this is just some special kind of things that happen when you go to FOIL and some patterns we want you to pick up on. This lesson will be a little bit shorter than the other ones. Just trying to see you pick up on some of these binomial patterns. Now, this is not something you necessarily have to know, but it's going to be very helpful for helping you identify what we're going to do next. In fact, there's going to be one especially I'm going to make sure you know. Because when we get to factoring, which will be what we do in the next couple of weeks, it's going to be very important that you're able to recognize this one. Okay? Let's start with two binomials. Now, if you notice, these binomials are the same. A plus 2 times A plus 2. And the point is that A plus 2 times A plus 2 is going to have a special product that will always occur when we have something that's in this pattern. I say on here, can you think of another way to write this? Can you think of another way? Well, if you have something times itself, we could also write that as that thing squared, A plus 2 squared. So if we use FOIL and we go ahead and multiply this out, you'll end up with A squared plus 2A plus 2A plus 4, which becomes A squared plus 4A plus 4. Hold on to that answer for a second. Let's say I look at a similar thing, K plus 3 squared, or K plus 3 times K plus 3. This time I go ahead and use my FOIL to simplify. K squared plus 3K plus 3K plus 9. I ended with K squared plus 6K plus 9. Did you notice a pattern? If you didn't, let's go back and let's look at the previous slide. When I did A plus 2 times A plus 2, I ended up with this right here. Hold on, let me get my pointer out here. I ended up with this right here, A squared plus 4A plus 4. That was, I just destroyed it. That was A plus 2 times A plus 2. If I go to the next slide here, when I did K plus 3 times K plus 3, I got K squared plus 6K plus 9. Let's do another one. How about C plus 4 squared? When I FOIL these out, I'm going to get C squared plus 8C plus 16. Have you noticed a pattern yet? Notice the number we're multiplying. We have a 4 here. In the middle, I have an 8. In the end, I have a 16. The pattern for this is that if I have A plus B squared, it'll be A squared plus 2AB plus B. Basically, I'm going to take this number here and multiply it by 2, and that's going to give me the middle term. I can then take this number here and square it. That'll give me the last term. This is known as the sum of squares. This is one of our special patterns we're going to want to be able to recognize. We don't need the FOIL if we see this pattern because we know how it's going to come out every time. If you look at these three without foiling, I can tell you the answer to them. The first one is going to be A squared plus 4A plus 4. The second one, K squared plus 6K plus 9. The third one, C squared plus 8C plus 16. That's where this general formula is coming from. And there it is right there, the square of a sum, or as I like to call it, the sum of squares. Okay, go ahead and try to find the product using the above pattern of these. Do not FOIL. Just go ahead and try to use that pattern to get these answers. Go ahead and pause the video for a moment, try these, and then come back and see how you did. All right, if you went ahead and you tried these two, this is what you should have gotten for each one. X squared plus 10x plus 25, that one's pretty similar to the ones we just did. The middle term, 5 times 2 gives us that 10. And then the last term, 5 squared gives us that 25. If you're a little confused about number 5, the thing that's weird about this one is that we have a 3 floating around in the first term, that A term. You really got to take this formula to heart. A squared, 3x squared is going to give me 9x squared. 4 squared, B squared, is going to give me 16. The middle term is the weird one, 2AB. So for that, it's going to be 2 times 3x times 4. And if you went ahead and did 2 times 3x times 4, hopefully you got that equaled 24x. And that's what that middle term is going to be. That is a sum of squares, one of our special patterns we're going to be talking about today. Now, let's look at something a little bit different. G minus 5 times G minus 5. Again, if I go to FOIL this out, we can think of this as G minus 5 squared. And it'll end up becoming g squared minus 10g plus 25. Do you see a pattern? Hold on to it. Let's check and see what happens. What about if I have 4x minus y times 4x minus y? I can write it as 4x minus y squared. If I go ahead and I think about that, it would be 16x squared minus 4xy minus 4xy plus y squared, or 16x squared minus 8xy plus y squared. Do you notice a pattern yet? Here are the two next to each other. See if you can identify a pattern, what's going on here. Hopefully you got this pattern right here. Very similar to the last one we talked about, except it's now negative in the middle. The first term squared, the last term squared. The middle is 2 times whatever your two terms are that you're multiplying. This is called a square of a difference. Okay, so that's when we square a difference. Go ahead and try the product by using the pattern above. Once again, try these on your own. Pause the video and then unpause the video and check your answers with me. All right, if you unpause your video, take a look at my answers here. Number 1, you should have x squared minus 22x plus 121. That one's pretty straightforward with the formula. The second one's a little bit weirder. Our x and our non-x term are kind of flipped around. That's not a big deal. We can still go ahead and use the square of a difference. I got 169 minus 52x plus 4x squared. Now, for some of you, you might be looking at that and going, oh my gosh, that's not in standard form. You are correct. You could rewrite this into standard form by putting the 4x squared first. So you could rewrite it, just kind of like y equals mx plus b, where we switch and have the x first. But you could rewrite this as 4x squared minus 52x plus 169 if you wanted to. Now, let's examine a different type. This is my favorite one. This is one that's going to be really, really, really important when we start talking about factoring. If you look at this, let's go ahead and let's do the same thing we did before. Go ahead and use some FOIL and see what happens. Now, this one we can't rewrite. This one does not rewrite as something squared. It just looks like how it looks up here. Okay, that doesn't change. So let's go down here and see what happens when we FOIL. You should notice what happens to the middle term. 4a and negative 4a. Those are going to be combined to become 0. And I end up with this. Go ahead and try this one and see what happens. All right, if you try this one, let's check and see what happens when we FOIL. Again, you can see that middle term. I have a negative 10x and a positive 10x. Those are going to go away, and you should have gotten x squared minus 100. Mr. Guy, what's going on here? This is kind of weird. This is the pattern we like to call a difference of square. You should kind of notice these up here. And you should notice that this and this and this and this, where are these numbers coming from? Well, x to x squared, 10 to 100, a to a squared, 4 to 16. Hence why we call it a difference of squares. When you have a plus b times a minus b, those middle terms will always disappear. And we would be left with just the first term squared minus the second term squared. The name difference of squares. This one's very important to be able to recognize because later we're going to start talking about factoring and we're going to kind of want to do the reverse of this. Okay, go ahead and try to find the products with the above pattern. Okay, again, remember that middle term disappears. You don't need to FOIL. Just try to use the pattern and see if you get the answer. All right, if you go ahead and check your work with me, you should have these two answers, 49 minus w squared and 81x squared minus 9. That's going to be your solutions to these using your difference of squares. Again, very important to be able to recognize these patterns. These are the big polynomial patterns for when we're multiplying. These are the ones where you don't need to use FOIL. You can use your pattern. Now, if you're taking the keystone and you forget a pattern, it's not a huge deal. You can always still FOIL it and get the answer. But being able to recognize these will take away some brain power that you have to use. It'll make it a lot easier for some of these problems. This one especially, of all the ones we've talked about, this one right here is the number one that you need to know. If you forget all of these patterns, this difference of squares one, the a squared minus b squared, is really, really important. And you'll see later why it's going to be very important, but just make sure you know that one. That's it for the special properties. Make sure you finish the attached worksheet. Make sure you're keeping up with anything you've had to do this week.